Hello everyone, we are students of the Universidad Autónoma del Estado de Hidalgo and we are the Mexatech team integrated by Julio César Castro Mendoza,
Cristian Cabrera Velázquez,
and Eric Rios Montiel.
And we will present our project called HopeHand, which is a prototype of an electronic arm and hand prosthesis controlled by myoelectrical signals, which is designed and built for people who have suffered the partial or total loss of an upper limb.
In Mexico, one of the most important health problems that affects thousands of Mexicans every year are the amputation, which can be caused by different causes, such as vascular diseases, unintentional injuries, defects of congenital origin, or cancer.
Due to this current situation in Mexico, an electronic arm and hand prosthesis printed in 3D is proposed to solve this problem, which offers the same capabilities of a sophisticated prosthesis at a low cost, allowing it to be accessible to all the population that needs a device like this.
And now this our prosthesis. As we can on the screen, the prosthesis was designed and assembled in SolidWorks to be printed in 3D. This prosthesis has 4 degrees of freedom, elbow with 2 joints per finger, which allow different movements to be generated with the prosthesis.
As a control system, we are using 2 myoelectrical sensors that provides the most natural user experience possible. This sensor obtains the electrical signals produced by the muscles when I flex my elbow or close my hand. So that later, these signals can be processed by a Raspberry Pi Pico, which interprets these signals and according to the programming code, allows the movements of the prosthesis.
Now I am going to give you a demonstration of how the prosthesis works. Previously, we have connected electrodes to the long flexor muscle and bicep of my partner, and now we will connect the myoelectric sensors to these electrodes.
Now, I'm going to connect the electrodes. First, electrode for elbow. And now, I'm going to connect the sensor for the bicep. After that, it's ready to function our prosthesis.
We also have a routine programmed to show how the prosthesis grid works.
Currently, the hand is animated to movements such as opening and closing the hand and bending the elbow, but we are working to give the hand more freedom of movement.
Here, when I flex my elbow, the prosthesis flex her elbow. When I open my hand, the prosthesis open my hand. I close my hand, I open my hand, I down my elbow, I flex my elbow, I close my hand. And this is the function of the prosthesis. Now, the prosthesis can function without sensors. In this moment, the prosthesis functions without sensors. It functions automatically. Hophan has a production cost of $622, which is extremely cheap when compared to the price of other prostheses that exist in the market today. And with this, we are looking to be a cheap and accessible option for people who need a prosthesis, offering the same feature as existing prosthesis and even better. This prosthesis is designed in SolidWorks, which allows it to be customizable according to the age, weight, and size of the consumer. Since all people are different and therefore an universal prosthesis is not feasible. In Mexico, there are very few people who have access to a prosthesis due to different factors such as the economy of the country and the lack of institutions that manufacture prosthesis. So Hophan, due to its characteristics, is the right option to contribute and help the population that needs a prosthesis. And that is all.